Good morning and welcome to a revision for Cambridge National Award for Certificate in Engineering Design R105. This is a video that's been requested by some of the students. You've got an exam coming up really soon, so I haven't got time to do lots of videos. So what I'm going to try and do is present you with a couple of short videos that will give you a system for tackling some of the questions in the exam, in that it'll sort of guide your thinking. What we're basically looking at is something called FAM. So if we just very quickly look at the exam paper, the nature of the questions in R105 are to do with the design and the specification and the function and manufacturing of a product. Not the detailed manufacturing, just sort of thoughts about the manufacturing process and how to make it more efficient. So the questions are based around looking at a product. So here we've got a blender. Here we've got a multi-gym, and it'll be asking things like, the users, the anthropometrics, the ergonomics, how does it work, how does it work well, how do we make it safe, how do we sort of deal with the law, legislation. So there's 3 or 4 product questions there. They also ask you about components, things that you do with the assembly and the disassembly, how it fits together, how you're going to build the design, or use of modern materials, how to be sustainable in the environment, British standards, European standards, how we sort of make products safe, and also about design icons, things that you might recognise like Lego, Mini Cooper, brand identity, those sorts of things are all part of design. We need to look out for these starred questions, the longer questions, and we'll look at how you tackle those. This one's about the life cycle analysis. They're talking about raw materials, manufacturing, use and disposal. We'll introduce sort of talking about cradle to cradle. The process that we're going to introduce you to, the sort of system, if you will, that helps you analyse a product. There is an example of this that you can look at on Prezi that I've done. So if you look for Prezi and look for Ian Bates, https prezi.com/user/Ian Bates/ there are 69. Okay, so you're going to need to find, and you're looking for product analysis, and it's from the 9th of May 2015, which was from the last time I updated it, and it'll take you through function, aesthetic and manufacturing. And this looks at constraints, criteria, it looks at the anthropometrics and ergonomics, these sort of factors in part of your consideration for a design. So I'll also look at the learning outcomes. So these are the learning outcomes that describe the sort of vocabulary that you're likely to need to use in the exam. The language that we talk about when designing. So we talk about identify phase, design phase, optimize and validate. We use language like market research, focus groups, target market. So we're looking to encourage you to use that language in the examination. Right. To sort of look at the start process then, we'll look at the brief, if you will. This is the first part of the design process, if you will, and it's to do with how we find out what design we're going to produce. So here we've got a collection. If we looked here at the design cycle, we're looking at this identify phase and this early part of the design phase. So the brief is likely to come, doesn't always come from a user. It's not just about the user. The client might not necessarily be the user. For example, if we were designing a kettle or something, and it's something I'm going to look at in the next video, or possibly at the end of this video, the client might be a company, it might be a business that are designing a new product, and they'll come to you and say, we want to design a new product. And it's your job then to help them sort of rationalise their brief. So you'll ask them the sort of questions. So what is the context of the product? A multi-gym is going to be used in a gymnasium. A fan heater might be used sort of anywhere in the home. Kettle's used in the kitchen. What's the context of the product? Who's going to be the user? what are the user's needs, if you will, and the purpose of the product, what's its function, what's it supposed to do. For user needs, you might carry out something called a focus group. You might get together a group of people that use kettles and get them to talk about their needs. So you might have sort of some elderly people, who say, oh well, kettle hurts my hands, it's too heavy, I need it to be light, or I need it to be easy to lift. And you might have a couple of younger people, younger X-generation people saying, oh, we need something really, really trendy, the latest colours. So there's a sort of research that goes into this brief, so that the client will say to you, I want you to design a fan, a kettle, I want you to design a heater that meets some of these needs. Now, in addition to that, your task would be to do some research. Not just what do the users and the clients need, but also what's available, what materials are available, what manufacturing processes are available, what new technology can you apply to the design process. How are you going to innovate? It's a nice word. Is how are you going to make your kettle different? How is it going to stand out? And all of this then is going to start to inform a detailed product design specification. And detailed product design specification is going to be the point where you actually start a sort of the design process, if you will. Now remember, this is a cycle. So when you get to the product design specification, you might need to go back and do more research that modifies your product design. You might go and find out about more materials that will modify your product design specification. So it is a cyclic process. It does go round as it sort of becomes more defined, if you will, to the point where you say, right, we know what we're going to design. So the design specification is a much more specific document. It has a set of requirements that you need to be familiar with. So we need to talk to you about aesthetics, ergonomics, anthropometrics. They use the term here benefits and features of a product, on-off switches, what it does, its functionality, what features it's got. And they might not be things that are immediately obvious, like it might have rubber feet to stop it from slipping over. Again, part product safety, but that will be a feature, if you will. We're going to be talking about the product requirements. Again, features comes up. Function, how is it supposed to function? What's its job? What does it do? How does it do that safely? Performance, how quickly does it do it? How well does it do it? Does it quietly, loudly? There's all sorts of factors to take in consideration. You're always constantly thinking about your target group and the intended user and what they need. Again, we talked about context, so you need to establish very, very clearly what its working environment is. But it's easy to think about a product in isolation and not think about it throughout the whole day. What does it do? How do you clean it? How do you get into the things to get it clean? Is it safe to open it up and clean it? Here's the limitations, the constraints, the actual sort of practical parts of it: size, weight, function, limitations, appearance to do with aesthetics, ergonomics, is it easy to use, easy to lift, move around, and then we'll do a separate section because we'll be talking about life cycle analysis, and we'll look at the life cycle of the product, the raw material, the manufacturing, the use, and then the subsequent disposal. We will look at something to do with manufacturing considerations. Again, that might be a separate video, looking at manufacturing processes, just to sort of add in. But the thing with the design is as you're going to see in the next part of this video, it's very difficult to separate out from the design process any of these particular. You have to be thinking of all of this at once. Very famous designer once described design as a sort of explosion in reverse. There's lots of factors all going on that you need to be thinking about all at the same time. He said, and very sort of slowly you start bringing these things together. And he said, and eventually the whole lot just comes zooming in, and finally you end up with a product. And it's you're going to see that a little bit today. You can see all these things sort of floating around the idea of a product, but then it all sort of coalescing and coming into a centre. So let's get started with looking at a product. So I'm just going to pull back a little bit on there, just to sort of get the whole piece of paper in. There's space. Okay. So I mentioned earlier this mnemonic, these letters that I want you to use. And what I'm looking at is function, aesthetic, and manufacture. So how do I think about the design process? And this is how I think about it. I mean, you know, there are different ways of thinking about it. In it, you know, you've got different opportunities. I'm going to think about a kettle. I'm going to pick a product that's not in the exam. So here we have a kettle. And I want to think about. So we're about 10 minutes into the video now. So I want to do a 10-minute. I'm going to limit myself to a 10-minute analysis of designing a new kettle. So I'm thinking about. Now this isn't the design, this is just me thinking about kettles. So I'm thinking about, you know, what's the basic idea of a kettle? You know, it's a jug or a pot, you know, you can have different shapes. So I'm sort of perhaps I'm looking at an existing product before I start getting into the design. My kettle at home, it's got a base, the plug on the end, it's got a sort of handle, there's a little window, so that might be something I need to be thinking about. A spout and some sort of lid that opens and closes. So what is its function? What does it need to do? Well, it needs to be safe. That's one of the first things I need to be thinking about is safety. It heats water to 100 degrees. It doesn't need to get any hotter. It does that and then it sort of cools down again, and I switch it on again. It's got a little switch down here. I'm not sure that's the best place for the switch, to be honest. Again, this is part of the sort of thinking of the function of the kettle, and so it has to switch on and off. That's the on-off symbol. What else does it need to do? You've got to be able to fill it. You've got to be able to lift it. When you start thinking about a product, there's quite a lot that goes into. You know, we take things for granted. Things are quite obvious. It's only when you start thinking carefully about them, you start to realise everything that sort of goes into the product and what it actually does. So I'd encourage you to sort of, you know, you put product in the middle here, and then we're going to go around the analysis cycle. So the aesthetic. What about the aesthetic of the kettle? The shape, the form, the look, the colour. The feel of it, the textures, you know, all of these things need to be considered in a design. You go into a shop and you watch people buying kettles, you'll see them, even though the kettles are empty, you will see people, they'll get their hand and they'll lift the kettle and they'll sort of tip it around a little bit to get a feel for it. People don't buy just with their eyes, you know. We might think that we do, but we don't. You know, watch people buying fridges in a shop somewhere. You know, when you furniture shopping, you watch people, they'll buy a fridge, they'll open the fridge and they'll look at it, and then they'll sort of just close the door and listen to the sound. You know, people aesthetics is not just looks, it is the whole package, if you will. I mean, to be aware of, you know, the shape, the form, the look, the feel, the colour, the texture, the weight. Some mobile phone companies add weight to their phones just to make them feel that little bit more solid. Okay, so from a manufacturing point of view then, I need to be thinking about, remember we talked about budget, I'm going to talk about processes, that's going to be dependent on the materials, you know, what materials, manufacture, and the budget. So how my current kettle, I believe that was injection moulded. You know, it's not an expensive product. It's, you know, it's not a spun aluminium dish or anything else like that. It is just. I'm not sure if it's a one piece, because again, there's the heating element that fits in the bottom. So that you've got to think about the assembly. How did it fit together? So there's a lot there to sort of consider. So let's break that down into a bit more detail. It's got to be, you've got to be able to lift the kettle, okay? And we talked about the weight of the kettle, and that's going to be defined a little bit by the material that we choose, how heavy it's going to be. So we're starting to get into ergonomics. Which is the lifting of the kettle. How, if I'm lifting a kettle, And here's where the science, if you will, your understanding of science and engineering coming in. So there's me lifting a kettle. Okay, and I'm going to pour out some water. What I need to be conscious of, there's a weight there, there's a centre of gravity, if you will, the mass of the water pulling down. So, you know, there's a force times distance. I know older people complain about their wrists hurting because the weight, the distance, force times distance, it makes it difficult to lift the kettle. So they have, you know, alternative designs. So we might be looking at a design that actually has the handle just above. There's the spout. So actually the weight is straight down, so you can lift it without actually having any sort of angle to strain your wrist, but then you've got to try and tip it. So these things need to be thinking about. Ergonomics is about how it works, and then more importantly, how it works well and safely. So ergonomics, how does it work, and how does it work well and safely? And to some extent, ergonomics deals partly with the, you know, these textures. You know, if I'm going to make this safe and work well, perhaps I'm going to add a rubber or a grip here to make it safe. But also that's part of the look and the style of the kettle. You know, I can maybe choose a nice sort of set of colour. You know, oh, there you go. Let's have a nice lime green styling and put that with a. So that might be the on-trend colour as I'm thinking about the design. You know, what is the trend, but also how can I make that part of the function. Got a nice little window here so I can see how much liquid, so I don't want to overfill. That could be to do with the environment, saving energy, only heating the water that you need. Encourage people. As a designer, you can encourage people to be environmentally friendly. So we're talking about ergonomics, how it works well and how it works safely. And part of ergonomics is this term. Now they sometimes get mixed up. Anthropometrics and ergonomics get a little bit mixed up. Anthropometrics is measuring. Okay? Anthro from human, metrics from measuring. Measuring humans. Anthropometrics is basically how we measure people. So you need to be aware of your target audience, but basically people fall into, the majority of people fall into a category in the middle, you know, the sort of average, if you will, with some people, a few people on the outside, and then a very few people. You know, this might be height. Most people are of average height, but you get a few very small people, and you get a few tall people. So this is the sort of target market. But if you're designing something, you're trying to design for the widest range of people. Not absolutely everybody. You know, designing doors, not every door is 7 feet tall or 7 feet wide opened, but it's big enough for the majority of people. Perhaps not the average, because there's still, these people would still bump their head. So what we design for is what we call the 95th percentile. We cover about 95% of the people from there to there. The few people at the outliers, you know, but at the same time we think about car design. We make things adjustable. There's a question in the exam paper. I'll just pull the exam paper up, and it talks about a gymnasium here, and it says, give 4 ways in which the design of the multi-gym could ensure that it's suitable for a wide range of users. This is definitely where I'd be thinking about things like, well, I could make it adjustable, I could think about the different sorts of people. One student suggested that we take the chair away. If you just pull that back in, if you take this chair off and we make a slot where you can take this away, then somebody could put a wheelchair in. And one really clever student said, "Oh yes, but you'd need to tie the wheelchair wheels down, because otherwise, when they pulled on here, the person would lift themselves up rather than pulling the weights down." So it's really good thinking about, you know, the exact context and the user needs. Okay, so we need to be aware of ergonomics. We need to be thinking about how that product's going to work well, and every product's going to be different. So you're going to have to do this sort of thinking. One of the ways is use your imagination to imagine yourself. You know, get my hammer, imagine myself pouring a kettle of water and thinking about how that's going to work. But being aware, for example, anthropometrics would affect this shape here. You know, I need enough space for the size of the normal hand. You know, my hands are sort of average size, but you might have some with slightly bigger hands or smaller hands. How does the product deal with these anthropometrics, these measurements? And that feeds into designing the ergonomics to make enough space, to make a grip, to make it light enough for them to use. So, and there's a lot of that in the function, how it's working. We talked a little bit about the aesthetic. Yeah, again, like I said, you can't isolate these things, it all happens all at once. So we think about the function, the aesthetic, and we've started to consider the manufacture. So we can start to think about the materials and the texture. So, you know, for some reason I picked this lime green, so I'm thinking some sort of polymer would be appropriate, because, you know, they can come in a range of colours and they take a texture from the mould. You know, do we want a kettle that's got sort of little bumps on it, like a textured sort of, I'm doing that now and I'm thinking straight away, I don't know, actually that might be a nice look. You know, sort of a texture, but you would get that from the mould, from the injection moulding process. And this is where you as a student need to sort of make sure that you're really well informed of manufacturing processes from other parts of your study. So I'm just flicking through here. Here are my design notes. This is the sort of, I'll pull right back now just for a second. This is the injection moulding process. But this is how I would be revising for my examination. So I'm looking at polymer processing here. I can mould, form or join them. So I can injection mold, blow moulding, rotational moulding, extrusion or calendaring. And if it's a thermoset, then I can use compression moulding. You know, from Toad's FM, thermal optical electrical density, and part of the sort of materials process that we've been learning in school, we've got thermoplastics, thermosets and elastomers. You need to be reasonably familiar with these manufacturing processes. So that's the injection moulding process there. There's going to be a mould here, granules go in, there's the heater, the melted plastics can be forced into the mould to create a shape. And that would work. I could design my kettle using that process, but thinking about the manufacture and thinking about the assembly, my question is, how do I get the heating element that goes in there? How does that go in? Heating element. Assembly. And while I'm thinking about assembly, this gets me thinking about disassembly, because we're talking about life cycle. How do I disassemble this product? Okay, I want to be able to, when it's finished with, can it be recycled? You know, can it be repurposed? You know, in its function, can I reduce the energy? So reduce, recycle, repurpose, reuse. What can happen here? And I'll use a little terminology, another little mnemonic, which is mud. The raw material. Can I change the raw material? Can I change the manufacturing process? Can I change the use? And can I change the disposal? How I get rid of it? So I'm going to do that. Manufacture, use, disposal. So there's the design in there, that point there, before it becomes manufactured I've got the design. So I need to be thinking about these things like perhaps it comes apart so that you can just recycle the plastic and the electrical components can go somewhere else and be recycled. So I need to design it so it can be assembled and disassembled easily. The manufacturing process, that requires energy. I've done a little sum because what I'm trying to encourage people to do is think about using renewable energies for manufacturing. And again, the kettle uses electricity. Is there any way, maybe it could be solar powered, you know, is there any way that you can reduce the energy usage? What I was thinking there, I thought there was, if you made the walls insulated, there's the kettle, if you insulate the walls, does that give you the opportunity to keep the water warm so it doesn't cool? Because we often boil the kettle and sort of reboil it again. So maybe you could think a way of reducing the energy that's lost. And ultimately disposal. Now there's one or two things that can happen. Either it goes to landfill, which is bad, or perhaps it can go to support the environment somehow. Can you use biopolymers? Can you use new modern plastics that biodegrade? Let's put that word in there for you, biodegrade. So use a biodegradable polymer so that it can just go into the environment. Or perhaps even better still is, could it become a raw material? There's a technique here, or a term here, called cradle to cradle. So I use a raw material plastic here. I design my product so it assembles and disassembles easily. I use a low energy manufacturing process. In its use, it's thermally insulating, so it saves energy. And when I come to dispose of it, it doesn't go to landfill. The plastic is a biodegradable plastic that goes back into the environment, and the electronic components go back into the process and get repaired or get modified and go back into a new product. Or the plastic at this stage is, you see this now, you can see plastic bottles that are ground down and turn into fabric, into fleeces. So they're going from the cradle, the raw material, back round to the cradle, becoming a raw material. So FAM, function, aesthetic and manufacturing, taking you round a product, thinking, how does it work? What does it need to do? What does it need to look like? What are the manufacturing process considerations? What about the anthropometrics, the measurements? Who's it for? The target market, the target users? How well is it going to work? What about the safety? And I'll just bring that onto here, where I'll talk about British Standards Institute that test products to make sure they're safe for the UK, and also the certificate, or the European certificate, which is a similar legislation, a legal requirement, if you will, for selling products in Europe. You can get it done by the British Standards Institute. They would test you, as a manufacturer, you'd have to get this product taken to the BSI and you'd have it tested, both non-destructive testing and destructive testing to make sure it's safe. Plugged in. What happens if it boils over when there's no water in it? What happens for the safety? Does it automatically switch itself off, or is there a sensor in it that detects that it's overheating? What is the safety factors involved in the product? What happens if you drop it? What happens if you drop it and it's full of hot water? Does the lid stay closed? These are all very important things that you would need to consider about as part of safety. So I hope that's been useful. I hope it sort of gives you an idea of how to analyse a product and look at it. We will look at some of the exam questions before the end of the weekend, and perhaps do a very similar process, and then look at how we can write answers to the questions in the exam paper. But one of the first things I would like you to do, I would strongly recommend that you do, is you do a function, aesthetic and manufacture, do a FAM analysis. Definitely go and look at the Prezi for some more information. Have a look round that and see how that takes you through the function, aesthetic and manufacturing process. And I hope that sort of gets you started with your revision. And do well in the exam.